Do you want to know how to castle with the king and also how to put the enemy into a checkmate position? Watch this video to find out. Hello and welcome to part 31 of the series on how to create a chess game with ReactJS. In this part we are going to finish the castling move and we are also going to add the checkmate move. We have a small bug in our program. Right now we can castle with the king. However, if we move this pawn down, we cannot castle with the king anymore. The castling is being calculated inside of the referee and then the king rules. Right here we have a method for getting the castling moves. In this method we check if the king has moved and also if one of the rooks have moved. If they didn't move, we are going to calculate if the king can castle with the rook. Down here we have an array for the concerning tiles. The concerning tiles are being determined based off the rook's possible moves that have the same y value as the king, which should be the tiles right here, which is this one, and this one. However, the rook can also move to the left. We cannot see that because the board is 8 by 8 and we only see the squares which are present on the screen, but the rook does have in its possible moves also moves that go outside of the board. So the move right here will be 0, 0, and then right here we have -1, 0, -2, 0, -3, 0. And since the queen up here can also move in that direction and also has moves that are outside of the board, they will eventually match up, which means that one of the possible moves of the rook that has the same y value as the king, but has an x position that is outside of the board, will be threatened by the queen, which means that the concerning tiles right here will have the same position of one of the moves of the enemy, which will be the queen. In order to fix this, we are going to modify the moves that the rook can play. So down here in our rook rules, we have the left movement, and right here we are going to add a new if statement. If rook.position.x minus I is smaller than 0, we want to break. Which means if the destination position of the rook is outside of the board, outside of the left side of the board, we don't want to look any further, because if the first tile on the left is outside of the board, the second tile will also be outside of the board. The third tile will definitely be outside of the board. We want to stop checking if the move is outside of the board. We also want to do this for the right movement. I'm going to copy this over to here. And instead of subtracting I, we're going to add I, and we want to say is bigger than 7. We want to do this also for the bottom and the top movement. For the bottom movement, it's -I is smaller than 0. And then for the top movement, it's +I is bigger than 7. And we want to target the y-axis of the position and not the x-axis of the position. Great. So if we refresh the page, I'm going to recreate the scenario. Right now we can still castle, and as you can see, the queen is being blocked by the pawn. However, once we unblock the queen, we can still castle, which means that we have fixed our problem. I'm going to create a new scenario, which is for the right rook. And if we now try to move, we can see that we can also castle with the right rook. Let's clear the way for the opponent's queen, so she can also target the right rook like this, and we can still castle. Great. Onto the castling. If we drop our king onto the rook, our rook is gone. That's not what we want. Last time we left off at the board right here, and we had a method or a function which checked if we could play the move, and a function which would actually play the move. Inside of here we have an if statement, or we have the template for the if statement. If the move is a castling move, do this. How do we know if a move is a castling move? We know that it is a castling move if the move is being played by the king and the destination tile is a rook. So right here we want to check if piece, or if played piece, that is king, and board dot or pieces dot find same position as the destination, and then is rook, because we want to check that piece. If that is a rook, we know that it is a castle move. An important thing to note right here is that the rook should be of our own team, because if we take another rook, that's not castling, because it's a rook of the other team. Instead of doing it in the if statement, we are going to create a new variable right here, destination piece, and we are going to set it equal to this variable right here. We're going to cut this away from here, and we're going to place it right here. we now have the destination piece inside of a variable. Here we want to check if the destination piece is a rook and the destination piece is of the same theme type as the current playing piece, which will be playPiece.theme. I'm going to put this in a new line so we can read it better. And then we're going to create curly braces to enter the if statement. So if the move is a castling move, what we don't want to do is we don't want to remove the rook and put the king in its position. We want to move the king 2 tiles to the direction of the rook, and we want to put the rook on the other side of the king. So in order for us to do this, we first need to know the direction that the rook is in opposition of the king. So we say const direction, which is equal to, and then we can use the same logic that we had inside of our king rules right here, because right here we also had a direction based off the position of the rook in comparison to the king. So we can put that right here, but now it's not rook the position, but it is destination piece. And I see that I misspelled destination, so I'm going to rename this to destination piece, like so. Well, if the destination piece is position at x, which means the rook position, if it is minus the king position at x, which will be the played piece, the position at x, if that is bigger than 0, so if 0 minus 4 is bigger than 0, then we will have 1. However, 0 minus 4 is equal to minus 4, so it's not bigger than 0, which will result in minus 1. Now we know the direction that the king needs to move to, which is to the left, hence the minus 1. If we were to castle with the right rook, we would have a destination piece position at x of 7 and a play piece position at x of 4. 7 minus 4 is 3. 3 is bigger than 0, which leaves us with a positive 1. And then the king knows that it needs to move to the right, 2 times its direction number. When executing this move, we know that there will not be a piece taken, which means that we have just as many pieces as we have started with. So that means if we have 10 pieces or 20 pieces and we do the castling move, we still have 20 pieces. There are no pieces being taken. So instead of using a reduce function, we can use a map function right here. We can say this.pieces is this.pieces.map. And then inside of this map function, we can map each piece. So we are going to give the piece as a parameter. And then we want to say return p. And this is a really simple map function, which just returns the object as it originally was, and it will put it in a new array. So the map function is a little bit different from the reduce function, where the map function maps the array to a new array, and then you can change the type of the array, but in our case we don't want to change the type of the array. What we want to do is we want to modify 2 objects in this array, which will be the king and the rook, because we want to modify their position. However, with the map function, the resulting array will always have the same size as the beginning array. With the reduce function down here, the resulting array does not have to be the same length as the starting array, which is exactly what we want if we want to take a piece. Because if we take a piece, we want to remove it from the array, which means that the resulting array will have 1 piece less than a starting array. That is why we cannot use the map function right here, but here we can. Alright, so instead of just returning all the pieces, we want to do something with our king and rook. So if p.same piece position as played piece, this will be the king. Then we want to do something p.position.x, and then we want to add the direction to it, times 2. Then what we want to do is return it, but we can keep it like this. Else if p.same position or same piece position as our rook, which will be the destination piece, then we want to say p.position.x is equal to something. And what will this be equal to? Well, let's create the scenario again. So if we were to castle in this scenario, the king would move 2 spaces to the left and the rook would move 3 spaces to the right. However, if we go to the right side, the king would move 2 spaces to the right and the rook would move 2 spaces to the left. So in order for us to make it more generic, what we could say is, well, we want the rook to be on the opposite side of the king. So if we move 2 spaces to the left, we want to have the rook on the space that is on the right of the king. If we move 2 spaces to the right, we want to have the rook on the left side of the king. So in order for us to do that, we need to store the new position of the king somewhere. And we can do that right here. We can say const new king position is equal to plate piece dot position dot x plus direction times 2. And this will not be the new king position, but the new king x position, since you are only saving the x value right here. So inside of here, we don't need to reuse this logic, because that's what we have written up here. If we select this, we see that it is exactly the same as we did right here. So we can assign this to the new king x position. And right here, we want to assign the rook to the new king x position minus the direction, which would mean that the rook is on the other side of the king. Let's save this up. And one more thing that we need to do is when we go into this if statement, we don't want to come in this if statement or in this one anymore. So for now, let's just return true by default. So right here, if we are inside of this if statement, we say return true, which means that the move was valid. Let's refresh the page and I'm going to recreate the scenario. All right, so now if we take the king and we move it on top of the rook, we see that the king moves 2 spaces to the left and the rook moves 1 space to the right. Great. Let's refresh the page and create the other scenario. If we take the king right now and we move it on top of the rook, we see that the king moves 2 spaces to the right and the rook moves to the left. Excellent. So now there is still one thing missing, which is we don't calculate all moves anymore. So we want to grab the calculate all moves function call and we want to put it right here. So now let's recreate the second scenario once more. We're going to move the pawn up and the bishop to the side right here. And then if we castle, we cannot move with the king or the rook anymore, but we can move with the enemy. Well, let's do the same for the enemy pieces. If we were to put our rook right here and then castle, we see that it's castling. Excellent. Great. Let's test one more thing, and that is if an enemy is threatening one of our tiles. So right here, we will have, let's see, the horse attacking this one. And as you can see, we cannot castle because the rook is being targeted by the horse. However, if we move the horse out of the way, we can still castle. And if we do that, we have castled. Great. Let's open up our components file and then go to the referee right here. If we scroll down a little bit, we see that we have our to-dos. All right, so pawn promotion. Let's move our pawn to the other side of the board because pawn promotion has been done and we can transform into another piece and it still works. Great, we can remove that one. Prevent the king from moving into danger. Which turn is it? It's this king's turn. Well, right now it can move to the bottom or the right. What if we move our queen to this spot right here? Then we shouldn't be able to move the king into that spot anymore. We can still move down and we can also not move to the left side because this bishop is blocking its path. Great, we have fixed that. Let me show you one other variant. If we move the king down, the queen to here, king to there, and then the queen up, pawn down, queen down, the rook to here, queen here, rook here, queen here, rook there. It might be done more easily, but if we do it like this and then move the king to here and the queen to here, we now need to move the king up, or we could put the bishop in front of it or the rook in front of it so that it is blocking the queen. We cannot move with any other piece. We can only move the valid moves, which is great. We can remove that from the list. Next we have castling. Well, we just did that. If we move our horse to here and then move the bishop to here, we can castle with the rook right here and we have successfully castled. Great. We need to add a check. Well, actually we created the check because if we move the queen to this position, we see that we now have checked the king and that the only valid move is this move. We cannot do any other move, which is great. However, if we keep on doing this, the king won't have any moves left. And that is a scenario that we have not yet implemented. So I'm going to reset the board once more and I'm going to move this pawn to here. And then let's see, we're going to open up this pawn and move this to here. We want to move this down. Okay, so right now the black team doesn't have any valid moves left over. As you can see, we cannot move with a single piece. This means the next thing on our list, we have a checkmate. Alright, so we can remove the check. The next thing that we are going to implement is the checkmate. Once we have a checkmate, we want to display a dialog which says, this team has been checkmated, the opponent team has won. Restart, because we want to be able to restart the game. So in order for us to do that, we want to add a new model. So we're going to create a new div right here, and we're going to give it a ref. And this ref will be the checkmate model ref. And if we copy this over and go to the top, we can create a new ref right here. Const checkmate model ref is equal to use ref. And this ref will have a reference to an HTML div element, like so. And it will have an initial value of null. So now if we save this up, we should see no errors on our ref right here, which is great. What we then want to do is we want to give it a div for the model body again. And then we want to put some text inside of here. So we're going to create a span. And inside of the span, we are going to say, the winning team is ... exclamation mark. And then we want to create a button as well. And this button will say play again. Now let's save this up. And if we refresh the page, we see the winning team is ... exclamation mark, play again. Great. Well, one thing we want to do is we want to style this model. So let's give this an ID as well. And then what we want to do is we want to give this the name of checkmate model. Right here will be the model body. Class name is equal to model body. Let's save it up. And if we refresh the page, it's still looking the same. Great. Now, if we go to the CSS right here, we should see that we have some CSS for the pawn promotion model. We want to reuse this for the checkmate model as well. So instead of creating an ID for the model, what you are going to do is we are going to rename or remove this. And we're going to give it a new class name of model. And then we are also going to remove this ID. And we are going to add the class name to here as well, named model. Let's remove the hidden from this model right now. And now we see that the promotion pawn model is on the top. Well, if we close our index.css and open our chessboard.css, let's change all the occurrences of this ID, which we have selected with Ctrl D with .model. And if we now save this up, we see that we have a model which says the winning team is, and also the pawn promotion model. All right, we only want to see one of them. So we want to remove, or we want to add the hidden to this model. And now we see that we only have the pawn promotion model, which is great. We want to remove the pawn promotion model. And we want to see our checkmate model, because that is the one that we are going to style right now. Instead of rendering the items like this, we are going to add a new div for the items. We're going to put it right here. And now if we save this up, we see that the items are more close together. And then what we want to do is want to give a class name to this div. But what we could also do is we could write some inline styling. But right now we are going to use the checkmate body as a tag or a class name right here. And then this class name will be used inside the chessboard.css. Inside of a model, we have a model body. And inside of this model body, we will have a checkmate body. Let's save this up. And the checkmate body will have a display of flex. And then we will have a justify flex align, flex direction, my apologies, of column. And as you can see, now we have the winning team is and play again underneath each other. We also want a gap between the two items. So let's give it a gap of 48 pixels, which is looking great. Then we want to make the winning team a lot bigger. So we are going to copy over this selector right here. And then we want to target the span. Well, you could also give a specific class name to the span or do something else. But right now, we just want to target this tag. We want to give this a font size of 32 pixels. And then what we want to do is style the button. So down here, we want to target the button. And the button will have the same background color as one of these styles right here. So if you open up the inspector, we can grab the color of this style right here. Let's give it the background color of this. And then we see that we have a nice green background color. Let's give the button a color of white for the text. And then we want to have some padding on the button. So we want to say padding, which is equal to, let's see, 24 pixels and then 48 pixels. So which means top, right, bottom, left. So top and bottom are 24 pixels. Left and right is 48 pixels. We also want to adjust the font size to something bigger. Let's make it 32 pixels as well. Well, now we have a large button which says play again. Great. We also want to remove the border. So we want to say border none. And once we click on the button, nothing happens. Well, that's okay. If we refresh the page, still nothing happens. That's fine. That's fine. But what we want to do is we want to give a border radius to the button of 8 pixels. Great. So now we have our play again button. One thing we do want to add is we want to give the hover effect of a pointer. So if we hover over the button, we want to say cursor pointer. And you can use any cursor that you'd like. I prefer the pointer. As you can see now we get a nice pointer. You could also, for example, say use the crosshair. And right now you get a cool sniper button. Great. So we are going to go with the crosshair, or sorry, the pointer. And we have a basic button for the winning team. But the winning team is not ... The winning team should be the actual winning team. How do we know what the winning team is? Well, we are going to save this in our board. In our board, we're going to create a new property, which is winning team. And this will be equal to team type. And we're going to add a question mark because the winning team will not always be defined. The winning team will not be defined until one team has won. Until that point, no team has won, and then the winning team will be null or none. All right, so when is a team winning? Well, before we do that, let's first go to the referee, and then right here, where we say ... we want to say board .winning team. Let's save this up, and then we get nothing. And what if we hardcode this to our team? Let's say team type .our. What do we get then? We get W. And if we set it to opponent, we should get B. Yes, because that is the values that we have assigned to the team type enum. All right. But instead of saying opponent and our, what do we want to say? Board.winning team is equal to team type .our. If it is, then we say white. And otherwise, if it is not equal to our team, we say black. Let's save this up. The winning team is black. That's cool. And now if we change the winning team inside of the board to our team, the winning team is white. Great. So now we have a winning team right here, which is based off the winning team inside of the board. All right. But initially the winning team will be null. So then we see black. And that is because inside of our referee right here, we check if it is our team. So this will be false if it is black or if it is null, which is fine because we won't see this if the winning team is null. All right, we're going to give this ref a class name of hidden. And once a team has won, then we want to remove the hidden from here. How do we know if a team has won? Well, up here where we play a move, let's see, that's up here. We set the board and we return the clone board, we play the move and we increment the total turns. Right here in our play move function, we play the move and then we calculate all the moves. Inside of our calculate all moves function, we also check the current team moves. And then at the end, we want to remove all the moves for the team that is not playing. What we also want to check is if the team that is playing right now, if that team has moves. Otherwise, if they don't have any moves, it is a checkmate. So what we want to do is we want to say if this dot pieces dot sum and then p dot possible moves. So if any of the pieces have possible moves, then we want to continue or we want to return. Otherwise, we want to say that the winning team is equal to the team that is not playing right now. So we want to say this dot winning team is equal to the opposite value of the current team. So we want to say current team. If the current team is our team, then the winning team will be the opponent. Otherwise, the team will be our team. so. And this right here is a ternary operator. This is the same as an if else statement. Right here we say, if this is true, then opponent, else our. One thing that we want to add in here is we want to filter to the pieces where the team is equal to the current team. All right, so with this filter, we check all the pieces that are on the current team. If any of them have possible moves, return. We don't want to do anything else. However, if we don't return, which means that we don't have any pieces left or we don't have any possible moves left, then the winning team will be the opponent team or the team that is not currently playing. So here we set the winning team inside of the calculate all moves function. And inside of here, we should have access to that winning team. So let's console.log winning team. And then we want to say cloned board.winning team. If we now open up the console down here and open up the console, let's create a scenario where we can win. We can achieve that by doing this, 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 and this. In this position, black should have won and the white king cannot move anywhere, which means that we should not have undefined right here. Let's check what is going wrong. In our board right here, let's copy over this statement right here. And then what we want to do is we want to assign a variable to this. Possible moves is equal to this. And then we don't want to say sum, but we want to say map. And now we have a list of all the possible moves. And let's log that to the console. Let's refresh the page and create the scenario again. So now if we move the queen to here, we see that we have an array of 16, which mostly consists of empty slots, but we still have two moves left right here, which is a 4, -1 and a 5, -1. Well, I see what's going on right here. The king thinks he can still move down or to the bottom right. Well, this is exactly the same as we had with the rook, who thought he could move outside of the board on the left side. In order to fix this, we are going to open up the bar right here, and we are going to go to the king rules right here. For every rule inside of our king rules, or for every movement that we make, we want to check if it is still inside of the boundaries of the board. What we want to say right here is if destination.x is smaller than 0, or destination.x is bigger than 7, or destination.y is smaller than 0, or destination.y is bigger than 7. What we then want to do is we want to continue, or we want to break out of it. So right here we are going to add a comment. If the move is outside of the board, don't add it. We want to add this to here as well. We want to add it to the left movement as well, to the right movement, to the upper right movement, and well, to the rest of the movements as well. You might want to use a single function for this, so that we don't need to rewrite all this code everywhere. However, we are going to do it like this, and if you want to improve this, you can do that yourself. For now, this will be the basic. So if we save this up, refresh the page, move this one up, this one as well, and move the queen to here, we have removed the logging. We still see undefined. So let's add the login for the possible moves. And now try this again. If we move the queen to here, we see that we have an array of 16 arrays, and all the arrays are empty. All right, we can remove the log and the possible moves. And right here, what we want to say that the possible moves are not supposed to be undefined. And also the possible moves should have a length bigger than 0. So that means that we don't want empty arrays. Now, if we refresh the page once more and play the moves, we see that we get B, because the black team has won since the white team is in checkmate. The reason why it wasn't working before is because right here in this if statement, we were only checking if there was an array named possible moves. So if it was undefined, it was not there. However, if it was empty, it was there. So even though we had 16 arrays for all the pieces, which were empty, it still did think there were possible moves. However, since we say that the possible moves at length should be bigger than 0, that means that empty arrays don't cut it anymore. Alright, now that we have our checkmate, and we have in our referee a place where we can log it, we can now remove the hidden class from our new model, and we can show it. So right here, we want to say if cloneboard.winningteam is not equal to undefined, then we want to do something, and the something that we want to do will be the checkmate modalref.current.classlist.remove, and then we want to remove hidden like this, and we also need to add a question mark right here because it might be nullable, which is fine. Now, if we save this up and refresh the page and try to play the moves once more, we should see the new model appearing, and we cannot take any pawns, which is great. And we can also click the play again button. Nothing happens, and that is the next function that we are going to create. If we move down here inside of the referee, we want to create a new function, restart game, and this function will be called when we click on the button right here. So right here we say onClick is equal to restart game. And then once we are here, what we want to do is we want to add the hidden class back again to the model. So we want to say checkmate modalref.current question mark dot class list dot add hidden. And we also want to restart the game. How do we restart the game? We can do that by setting the board equal to the initial board. So inside of here, we want to say set board, initial board, and we don't want to use the initial board because then we have a reference. We want to clone it. So we want to say initial board.clone, and that is also something that we want to do with the initial board right here. By cloning it, we are making sure that you are not modifying the original board. Let's try this out one more time. We are moving the queen to here. We cannot move anymore. If we click play again, we can play again, and we cannot play any turns anymore. That is probably because we calculate the turns on the first time that the board is being calculated. Instead of calculating the moves right here, we can remove this use effect, and we can go into our constants, and then right here, what we want to say is initial board.calculate all moves. And now if we save this up, we still have all the moves, and we will still have them when we play again. So right now, as you can see, we still have all the moves that the board needs to know, because this one, the calculate all moves, is now being done on the initial board instead of on the copy that we have made inside of here. One more thing that I'm going to add is down here, we are going to remove the checkmate from the to-do because we have just implemented the checkmate. And down here, where we have our p tag, I'm going to add a little bit of context, which will be the total turns, and then we will have the number. So now it will not be that arbitrary anymore. It would also be cool if we could style it or center it. Let's give this a text line of center. And now if we save this up, we see that the total turns is nicely being displayed on the top in the middle. Well, if we open up our game and we move the pawn to the top, that pawn to the bottom, bishop to here, the knight to here, the queen to here, and this pawn to here, we see that we cannot castle because we cannot play twice in a row. That's correct. However, now that we have moved the enemy, we can castle. Great. Castling works. Check. Next up, well, if we move our pawn to here, move that pawn to there, move our pawn to here, we still need to do something else, which is this, because the opponent queen needs to move, and we move the queen to here. The king cannot move anywhere else, and the winning team is black. We have a total turns. If we play again, it resets to 1 again. Great. I want to thank you for watching. I hope you could follow along. Leave a like, comment down below, subscribe, and I'll see you in the next episode. Bye!